Good day everyone, we are the group 7 and today's video is we are going to answer the given problem and number 7 using the truth tables. Members Christine Joy Foronas, Angeline Gumapak, Chariza Tindoy, Rosalyn Sumambot and yours truly Stella Foronas. First, I will be answering problem 1. The first problem is P implies Q equivalent of not Q implies not P. As you can see in the truth table, they have a variable 2 which is P and Q. And also we have to unpack the implies P and Q and not P and not Q. In the third column of table, which is the P implies Q, if both true, the answer is true. If P is true and Q is false, the answer is false. If P is false and Q is true, the answer is true. If both P and Q is false, the answer is true. In the column 4 of table, which is the not P, if the value of P is true, we interchange it into false. If false, we interchange it into true. So the value of not P is false, false, true, and true. In column 5, which is the not Q, if the value of Q is true, we interchange it into false. If false, we interchange it into true. So the value of not Q is false, true, false, and true. In the last part of column, which is the not Q implies not P, if the value of not Q is false and not P is false, so the answer is true. If the value of not Q is true and not P is false, the answer is false. If not Q is false and not P is true, the answer is true. And both not Q and not P is true, so the answer is true. Therefore, the negation of P implies Q is equivalent of not P implies not Q. By the way, this is Stella Foronas and the next is Christine Joy Foronas.
And on our second problem, I am going to show that negation of P implies Q is equivalent to P and not Q through a truth table. In our first and second column are the values of P and Q, while in the third and fourth column are the negation of P and Q. I come up in that conclusion as I interchange the values in the first and second column. So if P is true, then in negation it turns into false. And if P is false, then in negation it turns into true. As I rather interchange it. The same method I applied in the fourth column, the negation of Q. In the fifth column, the P implies Q. If P and Q are both true, then it is true. If P and Q are both false, then it is also true. If P is false, then Q is true, then it is true. If P is true, then Q is false, then it is false. In the last column, the negation of P implies Q is to base it in the fifth column, the P implies Q. Since in the last column is negation, so I am going to interchange the values of P implies Q. As we can see in the table, in the fifth column, P implies Q. If it is true, then in negation it will become into false. If it is false, then it will become into true. The same in our first table, the first and second column are the values of P and Q. Then the third column is the negation of Q. Since we already know how to come up to conclusion in the third column, the negation of Q, we are going to proceed in the fourth column, the P and not Q. We are going to base our answer in the first and third column, which are the P and not Q column. So, if P is true and not Q is false, then in the last column it will be false. If both P and not Q are true, then it is true. If both P and not Q are false, then in the last column in the P and not Q. If P is false, then not Q is true, then in the last column it will become false. In the first and second table, in their last column they have the same values. Therefore, the negation of P implies Q is equivalent to P and not Q. By the way, this is Christine Joy P. Frones, and Angeline Gumapak will continue the third problem.
For the number 3, I'm gonna prove this equation using the truth table. The given equation is P implies Q is equivalent to not P and Q. To get the truth values, we have first get the first column. In the first column, let the value of P, we have true, true, false, false. Then the second column, which is Q, we have the value of true, false, true, true. In the third column, we have to get the value of P implies Q. So if P is true and Q is true, so the P implies Q becomes true. If P is true and Q is false, so the P implies Q becomes false. If P is false and Q is true, so the P implies Q becomes true. If P is false and Q is true, so the P implies Q becomes false. In the fourth column, let the value of P, we have false, false, true, true. Then in the fifth column, let the value of Q, we have true, false, true, true. In the sixth column, we have to get the value of not P and Q. So not P is false and Q is true, so not P and Q becomes true. If not P is false and Q is false, so not P and Q becomes false. If not P is true and Q is true, so not P and Q becomes true. If not P is true and Q is true, so not P and Q becomes true. The second column and sixth column are the same. It means are congruent.
P implies with Q is equivalent to P and Q to 0. According to the table, it is probably a little harder to believe, but checking a truth table shows they are in fact equivalent. These values are normally assigned as false or untrue.
In the fifth problem, we are using the third problem. We are going to find a form equivalent to P if and only if Q, which only uses the negation and or connectives. The values of P, if, and only if Q are shown in the table. If both P and Q are true, then it is true. If both P and Q are false, then it is true. If P is true and Q is false, then it is false. If P is false and Q is true, then it is also false. Here in the second table, we can see that the equivalent form of P if and only if Q is P and Q, or not P and not Q, which is T, F, F, and T. We came up that kind of conclusion based on the third column and sixth column. If P and Q is true and not P and not Q is false, then it is true. If P and Q is false and not P and not Q is also false, then it is also false. If P and Q is false and not Q and not P are true, then it is true. Therefore, the equivalent form of P if and only if Q is P and Q or not P and not Q.